we're going to get a new data set here. Now, we can also take individual level turtle variables at a given time using the get agent set. So for example, so what we're thinking about up here, NL command, all of these are reporters that you would want to think about at the macro level. This is the percent unhappy. This is the count of turtles with happy equal true. These are all overall macro level variables. You're taking the mean of something. These are macro variables. But the turtle snapshot is going to be these micro level variables, the things that belong to the turtles pretty much. Their who number. Are they happy or not? That true false. The percent similar, and that is a global, so it's going to be the same for all of them. So that really doesn't make sense to have in here, and you'll see when we run it that it's the same. But that's a global, so it's going to be the same for every one. Other nearby, and that's the count of the other turtles nearby. So that is individual to the turtle. And we want to pull this for the agent set called turtles. So if you have, let's say, you have a model where you have sheep and wolves, and you want to pull variables from just the sheep, you wouldn't put turtles here, you would put sheep. So you would just grab that particular agent set. Does that make sense? So when I run turtle snapshot, we get a new thing here. Remember, we had 2,452 turtles in the model. Pull it up here. We have their who number, whether they're happy or not. The percent similar, and again, I said it's the same for every one of them. And then the other nearby, this count. So this is the turtle level variables that we're seeing. And again, this is at the end of the model run, so everybody is going to be happy. If I took this at the beginning of the run, if I just set it up, and I'll show that, you'll see that and then I get the turtle snapshot, take a look at it. Now, some are happy, some are not. So at the beginning, there's a mix, and at the end, of course, it's all going to be that. So, any questions on this so far? I've been talking for about 20 minutes. Any questions? Yes?
If you wanted to do a bunch of batch runs and save the results from each run, could you say, like, run this 50 times
Yeah.
and just
Yeah.
keep on appending?
Let's move on to the next thing then. Yeah, that's next. This is just to get started to just interact and know how to interact with NetLogo from R. But then, and this is where I'm going to be a little bit embarrassed sometimes when I show some of this stuff, because my coding may not always be the most efficient, but it does work usually. Anyway, so
Not to be said for that.
yeah. So here's an example of it was actually, I made it in your class, but you your class. This was but my first class in the program here, but I didn't. I've been working on it since then, and it's a model of it's a modified model of Axtel's retirement model that looks at the dynamics of the Social Security Trust Fund. But I wanted to be able to run experiments on this thing. So I've already loaded these packages. Again, I'm going to set the working directory. I'm just doing the same stuff again. I'm going to load this model right here. And now when I pull this up, we're going to have a totally different model here. So this is a model that if I run it, if you're familiar with Axtel's model of retirement, the model is basically that there's a certain number of people that are imitators, and there's a certain number of people that are rational, and there's a certain group will retire at a certain age all the time, and then another group will retire at random, and then one other group will imitate their social network, the people around them, and will retire when a certain number of them reach a threshold. So you can see if I just run this, if I set it up and go once, we see the green turning red and orange, and this retirement decision, we see the retirement age fluctuating over time and leveling out. This trust fund here is sort of the addition here. They all pay into a trust fund. So we look at the worker to retiree ratio. We know with Social Security in the United States, it was very high in the 1940s and declined very quickly. And this trust fund was made, there's this whole thing about it. Anyway, the idea is, how would we run experiments on this and do it a bunch of times, as Kara was just asking. So I have an experiment list here that we're going to go through. This is where the sweeps are run. So the parameter sweeps are done on the following variables: the initial number of workers in the model, the total Social Security tax rate, the population growth rate, the retirement threshold, the interest rate, the retirement age, and the cost of living. And I'm probably doing too many sweeps and should probably just pick a couple of these. But anyway, for the time being, I'm just going to go ahead and run this whole thing. And see, so now it's running each time doing this and saving the results in R right now. Now there's a couple ways that this can be done. When I initially loaded this model, I didn't show any other way to do it. You can do it headless. And so by headless, it means that you won't see this screen here. It will never show up. And I don't know if that makes it go faster or not. I've never tried it. But you can interact with this just as you would during any other run. You can not view the updates, and you can just let it run. And that'll make it run a little bit quicker, too. I'm only doing 10 experiments. You'll notice I did the number of reps. This is the number of repetitions that you want to actually run each experiment. And so normally it takes so much longer, you know, obviously, if you pick 100 or anything. So I just did it for the example here, but what it's going to do is basically spit out a lot of summary results over here. Not all of them you need. Some of them are like intermediate things when you're making the final output that you want to get. But this is where if you were to take this script and have the data along with it that you needed, you could make this very repeatable. You could put it into a package, load the data with it, and always be able to do it the same way every time. And I just think that's kind of neat. So basically what it's doing right now is it's doing the sweep on population, which looks like this. I set up a couple data frames to store the data. I do it within a number of reps. I'm setting up, go. I'm getting a data frame. I'm appending what happens each time. I'm varying the parameters. And if I did some loops inside of this, I could make this a whole lot cleaner. I understand that. But for the time being, it works. I'm getting better at doing efficient code. I'm getting better at more efficient code. It's getting there. But
I think we all are.
Well, one of the things you'll find, I don't know how it is in the most recent versions, but NetLogo over its history has been notoriously not smooth in upgrading from version to version.
mm-hmm.
So if you get overly optimized to a version of NetLogo, there's a higher probability that it won't work at the next version change.
Mm-hmm. That's a good point. So, any questions about this or what's going on here?
Just one question, Harold. So when you use behavior space, it will run the model in parallel. Right. So when you run behavior
mm-hmm.
space, it says how many.
Right. So
if you use this computer, you can run like 16 runs in parallel.
Right.
And it's quicker.
Right.
Now in
I'm sure there's a way to do it, but I don't know how.
Right.
Yeah, I'll just be honest with you there. I haven't done that. I haven't made that leap to doing it.
So one
parallel.
of the things I've discovered with behavior space is if you do that and you record your data in some sort of external file, it'll get the two different threads will contaminate each other occasionally. And so
Ooh.
it becomes a real.
Well, it does. Well, touch wood, it hasn't contaminated too many of my results. My understanding, because it will tell you what run it's on. So if you do 25 runs, it tells you what run it is and which step. And yeah, it does get contaminated because step 3 in run 2 comes before step 4. Yeah, yeah. But I'm not being a computer scientist. Would that be? How much slower is it to run each one versus in parallel?
But you're saying it doesn't have clean separation when it's running in parallel?
Correct.
Of which data goes where?
Correct. That was my experience with the model I did.
Ooh. That's a nasty.
I'd have to call it up in Excel, and I could see maybe about 1% of my data, but I could see where it cut off the one of the recording things, and so I actually wrote a macro to clean that. With 1% of the data, I wasn't going to try to figure out how to solve it. I just cleaned those data lines out. Just deleted those. So.
Does time advance get you around that? Is the event calendar part of the problem, or did you get deep enough to see?
I don't know. I don't think so. I don't think so. And I could have designed around it, but as Harold said, you get something that works, and then you fix the minor problems and then move on.
Yeah, well, that feature is kind of beyond the good to know step. That's sort of necessary to know. There might not be 1% next time.
Yeah, it might not be 1% next time. But this doesn't have that problem because each run is done, is done and then completes.
Yeah, when you do your runs
It's not,
one at-
this is not multi-threaded.
You do your runs one at a time, you don't have that problem, for
Yeah.
sure.
All right. So it finished running and spit out the information, but I want to go on to just some of the other examples of how we actually maybe might think about, because right now we've been just dealing with models that exist and we're taking data from them. But sometimes, at least in a lot of the stuff I want to do, I want to instantiate a model with agents that have variables already, maybe based on an empirical distribution, or that exist inside of networks that may either be empirical networks or networks that belong to some sort of distribution. And then I want those agents to interact in that world. So one paper that I am working on and did and am still working on is this one right here, where basically we have the network of defense links, so formal defense agreements between countries, and in a certain years. So imagine what the formal defense agreement network looked in 1945 versus 1960 versus 1980 versus 2007, and then these agents run a modified version of Axelrod's tribute model, where it's in this network, using, instead of who their direct neighbors are, who their formal defense agreement neighbors are, and they have instantiations that's for a proxy for wealth, and they do all this stuff. But there has to be a way that we get these initial empirical distributions of wealth and defense networks into NetLogo in the first place. So that's what this is going to go through. So here I am. So notice here I'm not. I don't need the library NetLogo. Here I'm using something called iGraph, which lets you deal with networks and graphs, and then a few other things as well. So here I'm just bringing in some data. And then the next step, and this is just basic data cleaning. And this code is available. I have a GitHub, and it's on GitHub. So if anybody is interested in looking at it, they can do that. So this is just filtering both data sets and creating new variables for these different countries. Whoops, I didn't do that. Creating new variables for each country, and then making the graph object. So when we make the graph object, that's just using iGraph. And I actually want to talk about, though, adding attributes to an object here. So we can, inside these graphs, we can say for every node in this graph, we can give it a name. In this case, it's a country. We can give it a military expenditures per capita, which is a variable that it owns. We can give it the power that it has. The national material capabilities, its proxy for wealth. All of this stuff can be put as properties of nodes that exist in this network. And then we can easily create the graph file using writeGraph, this function from iGraph. We write it to a GraphML file, and that's important. The GraphML file is something that NetLogo can accept and bring in. So if you can make a graph in iGraph, which there's plenty of documentation on how to do that. If you can make that, you can export it as a GraphML and then use it inside NetLogo. So this is what this next thing does. It takes what we just spit out from here and uses it as the input into this NetLogo model. So again, we're requiring the NetLogo package, and I'm going to open up this new model. And here we can see we can pick from a few different years. We can pick from 1945. We can set it up, and each one of these nodes is a country that exists inside a defense network. So this is the same every year. They start with the same. They're resized according to their wealth, and we can see what it looks like in 45. We can set it up for 1960, 1980. You can see it grows over time. But these agents are now able to interact and make decisions according to this modified tribute model based on these networks that exist. So if we run this model forward, you can see that they get into little wars and little fights. These changes in global wealth are the large wars that happen. Countries can rise and fall. It's not always the ones that start out with the most wealth. A lot of different things can happen. But we want to be able to take this network and then analyze what comes out of it. So that's what the rest of these experiments do. So I'm going to do just 10 repetitions for all of these. And the first thing here is going to do the repetitions on a parameter sweep for all of these years, 1945 through 2007. Oops. That's what happens when you try to do stuff live. Anyway, what's it doing? All right, I'm just going to stop with that. It does work, I promise. I did it before I came here. Anyway, one thing that you can do is you can run, for example, for 1960, we can look at how one world looks that existed in 1960. If I run this, it'll spit out this graph. Instantiate experiment links. That's what I did. So all these little things matter. Experiment links. Where did I put that?
Yeah, what are experiment links?
No, it's just a variable that I need to instantiate. This right here.
Oh, length.
Yeah, length. So how long do I want to run the model? I'm just going to set this equal to 100. So now if I run this, let's see if this works. Good. So here's 1980, and I realize the axes are a little messed up. That's something I'm working on. I actually did this in Excel when I was writing the paper, but this is what it can put out. So each one of these is a country in a certain year, and you can see this is their wealth over time. You can see the United States in 2007 is the blue line. One of these is China. All of these are different countries, and we can look, and it automatically generated that. Here's 1980. But so what it's doing is it's going through all these runs and summarizing them, putting out all the different data sets over here that you can work with. The last thing I want to show is one thing. If you want to quit a model, one thing that you have to keep in mind, if to close it down, you have to use the function nl_quit. The last model I want to show is the food desert one. I did again for Dr. Crooks's class. So this basically I used R to I didn't clean any of the data coming in. It was some GIS data and some other things, but I used it to basically run this model. If you set it up and draw it, you can see here's where supermarkets and non-supermarkets or convenience stores are. We have a population here that exists. This is everything is empirically distributed, including the people, their population densities, and the supermarkets. But when we go here, you can see it simulates a week of them going and getting food. There's accessibility, but there's also other data underneath here. Each one of these has empirically distributed measure for health and heart disease and all of this stuff. And so I wanted to ask the question, can this measure of accessibility calculated from this model, and I'll show the accessibility heat map overlaid on here, can this be used to understand the differences in health outcomes across the DC area? So can accessibility to quality healthy food does it have any statistically significant impact on the health that is seen across all the different wards in DC? And to do that, it was kind of, NetLogo can do the modeling and stuff, but the analysis I had to use R for. So that's, I set this function called reset default values, because whenever I do a parameter sweep, I need to reset it to what I had at the beginning and then move one of them. So this is what I do in a lot of the things, is I reset the default values. That's a function. I set the number of repetitions to 10. So then this first thing, we're going to set this D star. So this is one of the parameters in the model that we want to sweep. We set it to a certain, a certain value, and we run it. I do for1 in number of repetitions, which is 10. We set up, we draw, we make the population, we do the command a certain number of times. We get the agent set, and then we run this regression. So this regression is running the properties of these people that exist in the model to accessibility, just running a simple regression on this. And then it's taking what comes out of that, so the coefficients of the regression, the summary, the coefficient of the accessibility, the standard error, the estimate, the p-value, all the different things we're pulling out of there along with a few other reporters. And then I'm just taking that and storing it in a data frame locally. So I'm just going to go ahead and pull this down to the bottom and run it. Any questions on what I'm doing there? I mean, that's basically what it's doing right now is it's running through each one, loading it, and running through the parameter sweep right now. It's doing a parameter sweep of D, this thing down here. So, and now it just went to a different one. So it's running through them, and it'll do this for a series of these. That was essentially my talk. Like I said, some of this code is available online, and some of it I'll make available after this if anybody has any questions. But any questions, I guess?
Can you disable display?
Sure, absolutely.
When you run from R.
I can just do this where I don't view the updates. Or there's another option when I actually load the model. If I go up here to where it says NL load model or NL start, you can do it where you can specify it as being what they call headless. And so you'll just use NetLogo as the engine, and you won't actually see it ever pop up.
So is that in the NL start command is just like a comma headless, or?
Yeah, it's going to be, well, it's running right now, but if it, this is the thing I was going to say, R marries NetLogo. This is where I learned a lot about the R NetLogo package. This is the guy who wrote it, Jan Seal, and this has a great introduction. If you want to read through this, this actually does, I think, a much better job of laying out how it does than the R documentation for the R NetLogo package. This one, he goes through some examples and shows a lot of stuff, a lot of detail. So this, I would recommend it. You can just search it, R marries NetLogo, and but the guy who wrote it, it's Jan Seal, and you'll be able to find this.
Carl, did you play around with any of those graphing examples that this article provided? Like they had some 3D graphing and. I've
done 3D graphing. Before, not for this, not necessarily be pulling stuff from NetLogo, but I have done some of that, but I don't have any of that.
Yeah, I was just curious what your perception was of how easily it was to apply some of this stuff. The graphing that this article recommends. This article right here? Yeah. Yeah, they have some box and whisker charts and.
Yeah, I mean, it really just depends on what you're trying to analyze, though, right? He goes into a lot more detail than I'm going into here. But this is all really R, and not so much connecting R and NetLogo. This is all, he's taking stuff, just data sets that were generated from NetLogo and showing how he used R to do fancy analysis with them. Whereas this talk, I guess I was trying to focus more on just how you would connect them up in the first place. But R has a ton of different ways you can analyze the data, visualize it, and model it further. Yeah. Yes?
Have you looked at all of the links between NetLogo and Repast?
I haven't. I'm not too familiar with that.
Repast supposedly had pretty good connections to stat packages. What I haven't seen yet, although they announced it 10 years ago, is a really good connection between Repast and NetLogo.
Yeah, so the idea is if you know how to do NetLogo, you could move your model into Repast, and then Repast has much better facility to move into S++.
Right.
They have a relogo package that can do that. So if you have a NetLogo model and want to put it into Repast, you use
They
relogo.
say they have that.
They have it. It's documented, and Jonathan Oz something is that he has paper on this, and it's documented on the Repast website as well.
I've seen a couple of spectacular fails to try to ingest a NetLogo model into Relogo and get it working in Repast, so I don't know how good it is. I mean, I don't know how good the facility is now. I know Repast works well once you get a model working in it.
Harold, a suggestion from online, some people are asking if you can make some of your code snippets available.
Yeah, so here we are. These two things are actually on GitHub already, and then I'll make available this first one, the RNetLogo example with the shelling model. I'll put that on GitHub as well. So.
Can you tell us where on GitHub?
Yeah, it's just H Walbert. If you just search that, you'll find it. H Walbert on
How do you
GitHub.
spell?
HWALBERT. So H and then Walbert. Well, that's it for me. That's all I have for now. Unless there are questions, I'm done.
Well, thank you very much, Harold.
Thank you.
And feel free to hassle Harold towards the end of the semester as you're doing your projects. You're trying to get this up and running.
Well, I'll be looking to finding out in a year how you've managed to embed it within the experimental design package of R, so you can do a whole experimental design and report the results. You'll burn some midnight oil getting that to work.
What I'd like to the end goal for a lot of stuff, I'd like to put it into a package where I have the data that's used, if any, at the beginning, just the raw data. It shows how it's all clean. It then has a script that does the experience in NetLogo, pulls it out, cleans everything, and then visualizes everything, and then I can just put it into an R Markdown document, embed it all into one thing. It'll be an HTML, and then I could just give that HTML document to anybody. And then you could also have that package too, and then run it yourself.
One suggestion I would make, and I mean this is for all modelers anywhere in general. Modelers like to do digits in, graphics out. If you ever want to federate two models, the graphics out had better be accompanied by digits out, or the next model won't be able to figure out what the input looks like.
The data sets underlying each visualization.
Yeah.
Yeah, and there's really no reason to do design of experiments if all you're doing is pretty graphics.
True, but then somebody asked the question, does this one instantiation you showed me represent the range of what could happen in this scenario? You're stuck for an answer.
Yes. Sarah, that's good. That'd be quite useful.
I hope it might be useful. Yeah.
So I did look up Python. There's some attempts to do this for Python, but they don't have all the commands built in. For example, the input command. Yeah. So it's much more immature than this. I think it's part of the problem is that. What is R's relationship with Java? Is R connected with Java?
No, it's mostly like C and C++.
I don't think so, Ken.
I can have a good memory. All the packages.
Isn't there a little C++? It's all C.
Part of it
Everything.
because you only
And that's another gotcha in there, because NetLogo does sit on Java. And Java has some interesting undocumented features.
Well, isn't Java built on C or C++? Yeah. So at the end of the day, they're both built on C. Just one is a level removed.
The problem with being built on Java is Java can do some interesting things with floating variables that you didn't realize it was doing.
Oh yeah. I hope this